Quince? Andiyan si Quincy?
Wala yata dyan.
Marinig ako?
Yes, Jai.
Andiyan si Quincy?
Disconnect ata, Jai.
Sige, tayo na lang muna, Rosel. So, we are the group 1 and we will be discussing to you our lab activity yesterday entitled Measuring Mass. So, here are our objectives. First is to determine the different types of devices used to measure mass in QC laboratory. Second is to observe the effect of the temperature, moisture gain, and electrostatic charge in the weight of samples. Third is to compute the correct mass of the sample using the buoyancy error equation. So so the instruction was to draw an analytical balance, label its parts, and indicate their functions. So here we have the analytical balance. And these are the parts. Itong nasa taas, paano ba ito mag-annotate? So this is the draft shield. The draft shield is the removable glass shells that prevents air currents from causing the balance band to move. So ito yung parang nagsisilbi na barrier niya from the outside environment. So pine-prevent niya na makapasok yung air kasi yung air is nagko-cause ng sensitive change sa weight. So next is the level indicator. So the level indicator is used to check the balance level. Next is the display indicator. The display indicator is designed to view the weight of a container or sample. So dito natin nakikita yung weight mismo or yung number na nag-indicate ng weight ng ating sample. So in the left side, we have the level adjustment feet. The level adjustment feet is used to adjust the level indicator. So kapag gusto nating adjustin i-adjust yung balance ay yung level indicator, iti-twist lang natin yung level adjustment feet. Next is the power button. So yung nasa center na button, yung power button natin. So kagaya ng iba na devices, ang use ng power button is to turn on or off the analytical balance. So sa right side naman is the tare button. Tare button is used to reset the mass to 0. So bago tayo mag-start mag-weigh, kailangan mo natin siya i-reset to 0. So next is the balance pan. Yung nasa gitna is what we call the balance pan. Balance pan, it is where you place the sample. Next, last is the doorknob. The doorknob is used to open or a door handle that serves as the indication to pull or slide backward to open.
Clean.
Quens?
Nadunggan ko.
Okay.
For the types of analytical balance, first, the macro balance. So it is a type of analytical balance with a maximum capacity ranging between 160 and 200 grams, and with measurements that can be made with a standard deviation of 0.1 mg. For the semi-microanalytical balance, are used for weighing small sample amounts down to the micro range. This balance comes with a readability or precision of 0.01 mg with maximum loading of 10 to 30 grams. For microanalytical balance, it is an incredibly sensitive balance that can measure the weight of minute and delicate objects. This balance is incredibly precise, down to the zero point 0.1 milligrams, and can measure everything from a feather to a fruit fly. Next. For the single pan analytical balance, also called a constant load balance, the single arm balance has 2 instead of 3 knife edges with 2 arms of an equal length. Single pan balances use a reference mass or substitute weight to determine the unknown mass of the object being weighed. The smaller arm is the balance pan and has a full complement of weight suspended. The longer arm holds a constant counterweight with a damping device built into the beam. For electronic analytical balance, many modern electronic balances have a precision of 1 part in 107 at full capacity, and the accuracy is usually comparable. Electronic balances need to be calibrated with known masses prior to use. Due to the sensitivity of the measurement, air pressure and humidity can alter results. To prevent this from happening, most electronic balances are covered in glass. For the weighing techniques, A. Weighing by addition. For weighing by addition is an estimating methodology used for considerably greater sums which are less delicate to external impacts. The process of weighing by difference is totally different to the weighing in addition. In weighing in addition, you first measure the weight of the container that will contain the reagents, enter the balance, and then add the desired amount of reagent to measure its weight. For weighing by difference is the most exact and precise option to compute the mass of a certain sample. This methodology includes repetitious weighing of a measuring container containing an amount of solid reagent. By measuring the gross weight or the weight of the sample with its container and subtract it with the weight of the container, you can find the net weight or the weight of the sample reagent.
So number 4 is the weighing errors. So first is effect of temperature. For this test, it used a test tube to determine if different temperature can affect the weights of different samples. So basically, titingnan lang natin kung yung temperature ba is may effect siya doon sa weight ng ating sa weight ng ating samples. For convenience, we use beaker to contain the test tube for stability in weighing. Put the beaker on the top loading balance and press stir for the balance to reverse at 0. Then, weigh a clean, dry test tube and record its weight for the room temperature. So first is yung room temperature, ang i-weigh natin is in room temperature muna siya. Tapos after natin ma-record ang weight niya is mag-place na naman tayo ng same test tube inside a freezer for 1 minute. So in short, palamigin natin siya and then i-weigh na naman natin siya ulit. For the third time, Place the same test tube on the Bunsen burner to increase its temperature for 2 minutes. So in short, papainitin na naman natin siya ulit and then i-weigh na naman siya ulit. So below are the results of the experiment. So kapag cold siya is ang weight niya is 14.02 grams. Pag nasa room temperature lang, 13.99. Kung hot siya is 13.96. So, based on our observation, as the temperature increases, the weight of the sample decreases. Kasi kung mapapansin natin, kapag ilalagay natin siya sa freezer, bababa ang kanyang temperature. So, ibig sabihin, as the temperature increases, the weight of the sample decreases. So, kay nagbaba ang kanyang temperature, so tataas ang kanyang weight. And if the temperature decreases, the weight of the sample increases. So same sa hot, dahil pag hot siya, mas mataas ang kanyang temperature, ibig sabihin bababa ang kanyang weight. Letter B is the effect of moisture gain or evaporation. So for this test, the watch glasses containing sodium hydroxide pellets, ethanol, and sulfur were used. So reweigh each sample using a top loading balance. It is aimed to know if samples subjected to air have effect on the initial and latter weight. Record the final weight. So here is ang observation namin is if sodium hydroxide and sulfur is subjected to air, the latter weight increases, but when ethanol is subjected to air, the latter weight decreases. So sa letter C is the effect of electrostatically charged weighing materials. A clean, empty, and dry plastic weighing cup was weighed beforehand. With a woolen cloth, rub the cup using it for 1 minute. Then immediately reweigh the weighing cup. Record its weight. So here we have from 3.9094, naging 3.9087 siya after i-rub yung kanyang after i-rub ang woolen cloth sa cup. So therefore, electrostatic charge decreases the weight of the sample. So sa letter D is the buoyancy error. Buoyancy error is the weighing error that develops when the object being weighed has a significantly different density than the standard weights. So ibig sabihin, ginagamit daw ang buoyancy error para malaman kapag ka daw yung object na i-weigh natin ay significantly different ang kanilang density at ang kanyang standard weights. So this error has its origin in the difference in the buoyant force exerted by the medium on the object and on the weights. So correction for buoyancy is accomplished with the equation. So using this equation, isosolve natin ang correct na buoyancy ng ating problem ng bottle. So a bottle weighed 7.6500 grams empty and 9.900 grams are after introduction of an organic liquid with a density of 0.92 grams cubic centimeter. The balance was equipped with stainless steel weights. So density is equals to 8.0 grams per cubic centimeter. Correct the mass of the sample for the effects of buoyancy. So show your solution. So ang ginawa namin is, since kulang ng 0. Tama yan. So from 9 point, ang kanyang ang kanyang ang 9.9700 grams na nakalagay dito or 9.97 grams is nung meron ng laman yung bottle. So yung empty bottle is 7.665 grams. So din-deduct namin sa ang empty bottle doon sa bottle na may laman para makuha namin kung ilang grams or weight yung sample. So yung sample is 2.32 grams. So ang ano yun? So ang weight ang density niya is 0.92 grams per cubic centimeter, which is the DOBJ object ito eh. The D object and the D air is the 0.0012, which is the normal value or the constant value of the air. And the D weights is 8.0 grams, which indicates the density of the stainless steel. So first is substitute muna namin siya doon sa formula, and then tapos yun ang weight 2 natin is equivalent to 2.32 grams, and then solve lang namin siya, simplify, and then 2.32 grams added to 2.32 grams multiplied to 0.00154347 blah, blah. So 2.32 grams multiplied to 0.00154347,826 plus 2.32 grams is equals to 2.322678,087 or 2.3227. So therefore, the correct buoyancy is 2.3227.
So for the guide question, nabunggan ka guys. Ayo, nabunggan ka dili.
Madunggan ka sa
Hinay.
Hinay.
Bago. Wait lang. Hinay dapon.
Chokes na.
Okay. So question number 1. Give a generalization of the effect of temperature in the rate of material. So, kung naminaw na din na actually na-mention na sa ni Jai, ano lang na ulitin lang ako na increase in temperature can decrease the sample of mahina din sa'yo. Nakasignal. Increase in temperature decreases the sample rate and vice versa. Kung mag-decrease ang temperature, magtaas ang weight sa sample. Therefore, we can say that it is inversely proportional. And somehow, ang moisture content and the sample temperature, yun nga ang nakaka-apekto sa weight. But there is na include na mo ang moisture. Mag-focus lang ka sa temperature for question number 1. So, again, if the temperature is increased, the sample of the weight decreases. And if the temperature is decreased, the sample is the weight of the sample increases. Next, please. Number 2. Give a generalization of the effect of moisture gain or evaporation on the weight of materials. So in here, increase in temperature could result to evaporation of moisture of the sample, making it somewhat light in room temperature. and decrease in temperature, the moisture near the sample condenses, making it somewhat heavier than the sample weight in the room temperature. So, sa ano, kung temperature, mag-evaporate yung mga moisture na near do sa sample. So, mo tong somewhat lighter ang iyahang weight. Though dili bang gid sa ingana gud depende sa ginaway ni mga material pero according sa akong nabasa dili bang gid sa ingana gud like kadako jud ang iyahang difference pero somewhat ano sa mag-lighter. And as well as kung mag-decrease ang temperature, ang mga moisture is mag-condense so somewhat affected siya as heat than the sample weight in the room temperature. Next slide. Number 3. Nadunggan yung bata ang gumain. Sorry lang ako, nadunggan yung sulinan ng Number 3, give a generalization in the effect of weighing chemically charged materials on its weight. So, ang charges, maka-affect sa weight. As Jai mentioned kanina, electrostatic charges decreases the sample weight, which will result to error and inaccuracy sa kanang weight na imuhang makuha. So, the electronically charged materials can be difficult to weigh as the static charges can cause unstable balance and reading and measurement risk, leading to slow and inaccurate weighing results. So, to elaborate this more, di ba, halimbawa, I mean, kailan man tawag, kanang electricity. So, electricity, di ba, is na ay charges. However, ang materials na atong ginagamit, for example, sa lab, nag-dry ta og beaker and then girab na to sa with a cloth. So, ang drying, ang beaker dito is ang insulator. Tapos, kung irab na to sa, di ba na ay friction na mahitabo. And during sa friction, kung, kung ang insulator is comes with contact with the surface, so di ba nagka-friction na, somehow nag-produce sa og electricity wherein ang electricity has charges. So therefore, ang charges maka-affect sa weight which is decreases the sample weight. Na-get niya o libot ang pag-ingon. Ang ano na lang, ang charges maka-affect sa as it decreases the sample weight. Ay dali lang. I-follow up lang nako so nganong maka-affect man ang charges dito sa weight sa ano. So, di ba nakaproduce sa og electricity, sama tong electricity is an energy. Ang energy man gud dito nga mabuo through friction, matrap siya sa insulator. So mao na tong ginatawag na electrostatic energy. So I hope it's clearer. Then number 4, discuss the principle of balance. First, close the balance door. Kailan naman to, di ba, tong weighing chamber or daghan mo sa tawag, weighing chamber or glass door. Close the balance door then. While weighing an object, in order to prevent air currents from disturbing the reading. So, dapat naka-close sa kung mag-weigh na ta. When finished, the operator should close the balance door to prevent dust and dirt from entering the balance. So, which is realize na dako kay pagmali diba dagan kay mistakes na nahimo pag analytical balance kay wala kay pa na educate din sa tama na paggamit sa analytical balance o ginabalhin-balhin na to sa area. So, siguro dagan kayo errors dito sa ato ang gipang way for sure. And only glass, ceramic, metal or plastic objects and containers should be placed in direct contact with the balance pan. Do not handle objects to be weighed with bare hands. So, guilty ba tayo? Nakita mo sa design na kung marag kaya-kaya lang ang chemical na ginagamit, ikalawa starch lang. Marag, ang isa kamot naka-gloves, ang isa wala. So, beware. Then, moisture, grease, and dirt on your fingers will affect the weight of the object. So, need na to mag-gloves. Kay carrier ba kaya to ang kamot og hugaw. So, maka-affect ito sa weight. Next, guys. To be weighed accurately, all objects must be at room temperature. A warm object sets up convection currents inside the balance enclosure, which will make an object appear lighter than it really is. So, it's as the same kanina, kung mag-increase ang temperature, maka-affect siya kung mag-light ang weight sa sample. Also, warm air inside the enclosure is less dense than the air that it displaces, and this also leads to a negative determinate error. And never weigh chemicals directly in contact with the balance pan. As mentioned kanina, dapat magamit ang mga containers or beakers and so on to weigh these samples. Use containers as beakers as bottles. All objects and materials that have recently been removed from a desiccator will absorb moisture and thereby gain weight. It is therefore good practice to record weight after identical time intervals. Napapanitin tayo, no? For example, if you're taking crucibles to constant weight, okay, no? Always record the weight of the crucible exactly 5 seconds after having placed the crucible on the balance pan. So, nag-record ka, niya usay baya kay pulihanay lang diretso bala na lang. So, mistake would not occur. Using this technique, it is possible to minimize the effect of moisture absorption. And another mistake natin mahimo, the use of weighing paper must be strictly avoided when using an analytical balance. Kasi sa'yo, nagagamit lang kag white paper na gibundok lang sa kuan, kilid-kilid. Do not spill chemicals inside the balance enclosure. If a spill occurs, clean it up immediately kay maapektuhan ang pag sa mga sunod na mga i-sample. Yan lang.
So, before ako mag-conclusion, may i-clarify lang ako. So, dito, na mali pala ako dito sa observation kasi dapat pala is directly proportional sila. Kasi kapag ka mataas ang kanyang net weight immediately after transfer, bababa ang kanyang net weight after some time. So from 0.70 na sodium hydroxide, magiging 0.93 siya. So probably tumaas. Pag 0.09 siya, ethanol, bababa siya to 0.03. And for sulfur, from 0.87, bababa din siya to 0.85. So for our conclusion, so in this experiment, we were able to define the different devices used in the QC laboratory when weighing a sample. These devices are sensitive with moisture, air, hand grease, and temperature. Note that the relationship of temperature and weight of sample is inversely proportional, while Moisture and weight of the sample is directly proportional. The electrostatic charge increases the weight. Based on the calculation of buoyancy error, the correct buoyancy is 2.3227 grams. This happens when the density of the object being weighed is different from the standard weight. So that would be all. Thank you.
Okay, so do you have questions na you want to ask or you want to clarify the reporters before I will wrap up also the activity number 1? Wala? Sige. So, actually, it was my intention to go back to the basics, measuring mass. Kasi yung ibang mga batches actually, hindi sila nag-undergo nito. Diretso na siya sa mga QC talaga ng mga experiments. I go back sa measuring mass kasi based on my observation, bisag unsa na lang ang ginahimo sa mga estudyante when it comes to the use of the analytical balance. And then since this is QC, quality control, we are talking about quality. Therefore, dapat i-ensure nato na accurate ang atong mga measurements, they are precise, especially pag mag-testings ta no or mag-analyze ta og mga drugs kasi variations or errors sa weighing palang daan will really affect the product itself. So, appeal na dito ang effect sa product, ang stability sa product, tanan-tanan na maapektuhan. Kapag sa start pa lang, dili na tama ato ang ginabuhat. So, let's get to know more about our analytical balance because sa QC, we are not allowed to use other types of balance like mga top load balance, mga kanang mga triple beam balance na to, it is not permitted sa QC. So since we are talking about quality, then we are only allowed to use the analytical balance. So ato siyang ila-ilahon ulit because I believe kailan na jud mo sa iya bisag asa na lang ninyo ni siya ginadala. Naabot na ni sa 3rd floor, balik na sad sa 1st floor, balhin na sad sa animal house, bisag asa na lang yun naabot sa chem lab, physics lab. Okay. Nagproblema ako sa ato ang analytical balance kasi may problema na gyud atong analytical balance aside sa gitaya na siya kasi nganong gitaya na siya kasi kulang siya sa paglimpyo and at the same time we are not careful sa mga ginagamit natin na mga materials ato ang mga samples usahay na i-direct contact with our balance. So na siya, nagkaroon na siya og mga taya. Laagan kayo to ang analytical balance, no? And at the same time, there are errors sa mga ginahimo nato when weighing. So parehas anang giingon ni Rosel, usahay abri na siya. Abri lang, wala gina-close kapag naga-weigh og substance or sample. So naadjud tay daghang ginahimo during weighing na problema kayo siya. At the same time, class, actually sa quality control sa QC, kailangan kasi may weighing room. So mo na siya akong gi-request ila Ma'am Eroy last time. Actually, dugi na gid ako na siya request. Even kay Ma'am Charm. Na dapat kung gibalhin na tanan ang laboratory sa 3rd floor, dapat naa siya weighing room. Tawag na to ana weighing room na tanan natong balance dito siya nakabutang and dili na maglaagan ng ato ang analytical balance. So I was told na nag-purchase na daw ang school, ginapaabot lang og murag 2 or 3 additional na mga analytical balance kay di na gyud magsilbi atong analytical balance na nag-iisa sa school. Kailangan na gyud siya ilisan. Okay, and I'm not sure kung asa nila ibutang ang weighing room. Ingon, ang last time na ko na nadunggan kay diha sa tunga. Kanang, di ba sa 3rd floor. Di ba na anay mga harang diha na sa tunga agianan, murag butangan ata siya gamay nga room na mag-serve as the weighing room. Dito ibutang ang analytical balance. Okay, end of contract na si analytical balance na original sa school. So let's get to know the parts and functions of our analytical balance. Syempre, we have the weighing chamber. You cannot see an analytical balance without a weighing chamber. Naagid na siya kaninga part, this one, weighing chamber ang tawag. That is to reduce or even eliminate the influence of airflow sa atuang gina-measure. So, ang problema pareha sa giingon ni Rosel kagain na wa na gina-close habang gina-weigh. Na naadjud na siya purpose nganong naa siya weighing chamber. And then we have the so-called level indicator. This is the part of the balance that will indicate whether naka-level ba ang tama ba ang position sa kaning mga level screw or mga tiil aning kung sa layman's term pa mga tiil sa ato ang analytical balance, no? So mabalaan man na ninyo kay di ba na siya ring sa center, so dapat sa center gyud ang ring para naka-ensure ta na balance level gyud ang ato ang analytical balance. Kapag wala na siya naka-center class, meaning na dili tama ang iyahang weight na ginahatag, dili precise, dili accurate. Okay? So dito nato na siya gina-adjust class sa level screw kani diri mga tiil niya para mobalik sa center ang atuang ring. Okay, akong problema sa ato ang existing na analytical balance kay bisan unsa pa nimog adjust din ha sa iyahang level screw, di na gyud siya mobalik sa tunga. So dapat na gyud siya mag-retire. Okay? So you have the balance main body and then the display here where you can see the measurement. Okay? Let's continue. Now we have the glass door. So 3 places. Even our analytical balance in the school na a glass door. We only open this if we want to place our sample inside. But when you read the results, you really have to close the doors. Again, to eliminate the influence of the airflow. Kay maka-cause og variation or error sa readings. Wa ninyo gina-close. So kung makita ninyo dili pud na siya ma-stable ang reading, masige pud na siya lihok-lihok sa display kay naay airflow kay wala gi-close. And then syempre the pan, this is where you place the sample that you are going to weigh. Okay? And class, do not forget that there should be no direct contact between the object or the sample and the pan, especially if the chemical is highly corrosive, maguba jud atong pan ani magtaya. And then the anti-draft ring, so this is the pan inside, and then outside you have there the anti-draft ring that helps reduce the influence on measurements from the air drafts. Okay, protection pud na siya and additional protection from the influence of the airflow. And then the key panel, this is where you can see the buttons na like sa settings and sa pair kung gusto nato i-zero ang sa display. Yan nato makita siya sa key panel. Okay, questions sa parts sa atuang balance? Wala? Okay. So when you say analytical balance class ha, it's a weighing instrument na it's actually highly accurate and iyahang capacity depende sa available na analytical balance. It can accommodate 1 gram up to how many kilograms. And ang precision ani is at least 1 part of in 10 to the 5th or 10 to the power of 5 at maximum capacity. So ang mga modern nato karon na mga analytical balance actually very precise na sila and accurate, no? At full capacity ano na siya, it can exceed 1 part in 10 to the power of 6. Now na-discuss nila a while ago ang types sa atong analytical balance. Dali lang man ni siya tandaan kay macro, semi-micro, and micro. Siyempre ang macro mo ni siya ang katong larger capacity nato na analytical balance. In terms of precision, the same lang man sila, ang capacity lang niya. Kay si macro balance, 160 to 200 grams, si semi-micro, 10 to 30, and si micro analytical balance, 1 to 3. Okay? So, ang atuang dati, traditional nato na analytical balance is actually ano siya, 2 pans. So ingana iyahang nawong ato mga sa una pa ng mga analytical balance where on the other side you will place the object na i-weigh and then on the other side you will be placing weights. Kanang mga weights gani nga predetermined na ang ilahang mass. So naay mga weights na 5 grams, naay 1 gram and so on. So hangtod na magpantay na silang duha dinha, and that's the time na mao na siya ang iyahang ang final weight sa imong object. You just have to add all the masses of the weights nga gibutang sa opposite na pan. But after the double pan na analytical balance, we also develop na ato ang single pan na analytical balance na mas convenient siya gamiton and mas paspas ka makakuha og weight sa imong object. So this is how a single analytical balance looks like. Okay? So, pwede po siya maka-measure og 100 of a gram, even larger than that. So, ang ilahang difference is you have one pan only. So, dire weight pan, dini mo ibutang imuhang object. And then, may mga built-in weights pud ni siya. And, ano siya, class, maghatag siya, musiga ni ang iyahang lamp and mao na siyang indication na maghatag na siya og reading. And paano siya maghatag og reading, may mga since naa siya yung mga built-in weights dinhi, mag-ano pod siya, mag-determine pod siya kanus magpantay tong weight na sa imuhang gibutang and sa mga weights na naka-built-in din ha. So pag magpantay na ilang weight, meaning na ano siya reading for your object. So musiga na iyahang light and then it will give you again the measurement sa display. It's the single analytical balance. However, let's make our lives easier. We'll have the electronic analytical balance. So ang ginagamit na nato karon mauna ni siya. Na diretso lang, hay kay itong life. We will just place the sample in the pan and then it just reads after. Okay? So, natay techniques in weighing and akong problema, wala siya ginagamit, ginahimo sa mga estudyante. Bisag unsa na lang ang ginahimo, wala na technique sa weighing. Pero sa QC class, when we do analysis, we really have to follow the steps sa mga techniques nato. We only have two, weighing by addition and weighing by difference. Now, let's look at how are we going to do the weighing by addition. Okay, let's watch this video para kabalo mo ug unsa jud ang tama na weighing technique. So the first one is weighing by addition.
Weighing by addition. The objectives of this video are to learn proper weighing technique and to learn the weighing by addition method. To weigh by addition, you will require Kim wipes, a clean and dry beaker, finger cots, a spatula, a compound to weigh, and a laboratory notebook. Make sure you are wearing proper protective equipment. On an analytical balance, with all the balance doors closed. 0 the balance. It is important to never handle the beaker with bare hands, as the oils from your fingers add mass to the beaker. Handle the beaker with finger cots, gloves, or Kim wipes wrapped around the beaker. Place the beaker into the center of the balance pan. Gently close the balance doors. Wait for a stable reading. Once a stable reading is achieved, record the mass of the beaker in your laboratory notebook. Remove the beaker from the analytical balance and take it to the top loading balance. Don't forget to close the balance doors when not in use. Your laboratory notebook should be set up like this. Use a brush to clean the top loading balance of any dust or solids.
This is top load balance, not analytical balance.
Place the beaker on the top loading balance. Tear the top loading balance with the beaker on it. Chemicals should never be weighed directly on a balance. Remove the beaker from the balance. If the bench is dirty, it is a good idea to place the beaker on a Kim wipe to prevent particles from adhering to the outside of the beaker and increasing its mass. Measure out the desired amount of compound to within 10%. To check the mass of compound added, return the beaker to the balance. Add or remove some of the compound as required. Be sure that any excess compound removed is discarded into the solid waste container and not returned to the stock bottle. Once the desired amount is added to the beaker, return to the same analytical balance that was used to weigh the empty beaker. Be sure to never touch the beaker with your bare hands. Repeat the steps used to measure the empty beaker. 0 the balance with the balance doors closed. Place the beaker containing the compound on the center of the balance pan. Gently close all doors and wait for a stable reading. Once a stable reading is achieved, record the mass of the beaker and compound in your laboratory notebook. The mass of compound is the difference between the beaker and compound mass and the mass of the empty beaker. You now know how to weigh by addition.
Okay? Anything that you want to say na nakuha ninyo sa video? Just tanaw ninyo. Nagabuhat pa mo og ingato sa lab when you measure the mass of some...
I plead guilty, ma'am.
Ansa?
Likely applicable.
I plead guilty.
Nag-utok man ni ma'am.
Ansa?
Ma'am, nahuhulog man yung door.
Walang lock.
Walang lock, ma'am. Itulak mo, diretso yung door.
Yeah, you don't, you don't hold the analytical balance while weighing. It will add up to the error sa inyong inyong result. If 2 grams exact lang yung needed. Actually Isobel sa testings, though moingon na siya din og 2 grams, but you really cannot exactly measure 2 grams and maging source man gud siya sa variation. Mo to nga sa video, naggamit sa siya top load balance as approximation. And then, anha pa niya gisulod sa analytical balance. Mo na siya nga kailangan nimo i-record up to pila ka decimal and then didto na ta sa computation mag-adjust. Okay? Sa computation na siya mag-adjust. Dili ta kay how na kay ka if you can hit the 2.000 grams. But since it can be a source of contamination, masikag kuha-kuha sa imuhang sample, we don't do that sa analysis. kung read na siya din haog at least 2.5, then use the 2.5. And then mag-adjust lang na siya sa computations after. Niya magtapok pa jud mo no sa inyong analytical balance unya.
Same ang table ng ma'am, ng analytical balance at saka yung working space.
Mao gani kalisod ba oy, kalisod kayo. We don't really follow the correct procedure sa weighing. Kato ano pa lang to weighing by addition. Pero actually weighing by addition is not the most accurate way in weighing. Accurate na method, dili na siyang pinaka-accurate. Yes, kung 2 grams imong need, i-approximate sa siya sa top load balance. Tapos, usa nimo siya ibutang sa analytical balance. And then, para at least ang sobra kay mga point something lang. Pero i-record nimo appeal tong mga point something pag butang nimo siya sa analytical balance. Okay? So, ang weighing by addition class is you weigh first the container and then you add the sample after using the top load balance for approximation. And then after that, you weigh again the container plus the sample. And then to get the weight of the sample, i-minus na lang nato siya. Weight of the sample is equal to weight of the container with the sample minus weight of the container. That's how you do the weighing by addition. Kani step by step na gyud din gikan sa paglimpyo sa balance. I-summarize na lang nato siya. Mo to nga na lang nako siya. Container first, tapos dagdag niyo ang object or ang sample using the top load balance, balik niyo siya sa analytical balance, and then i-minus na lang nato to get the weight of this sample. So do not forget to use other containers no direct weighing sa pan. And then nganong dili siya the most accurate kay remember gigawas pa nimo imuhang katong in that case gigawas pa ang beaker, gipatong pa sa top load balance. So whatever is naa sa top load balance, it can add up to the weight of the container plus the sample na. Wala ba ta nagagamit og Kim wipes sa sa school. Kanang Kim wipes maano na siya. Una siya ang tissue paper na wala gud siya mga thread. Atong mga tissue paper man gud pag mabasa na kay mapilit na dito sa atong aparatus, or kung dili man siya mabasa ang mga thread-like particles sa atong mga tissue paper na magdikit dito sa ato ang glasswares na makakos og contamination or makakos og error sa measurement. Okay. O mabilin pa dito sa test tube, kapait ba sa life. Okay, so muna siya nga weighing by addition. And the next step is the next technique sa weighing, which is the most accurate one, is the weighing by difference. So let's see how are we going to do the weighing by difference. And let's see nganong siya ang most accurate. Sige. Ay, and dami. Kumugunin kita na gawin na. Okay.
Right, in this video we're going to learn how to weigh by difference, and we're going to do that using the top loading balance here and the analytical balance here too. In order to weigh by difference, start by taking your weighing vial, take the lid off and pop it on the top loading balance. You can then get your solid ready that you're going to be weighing out, zero the balance with your vial on, and then weigh in the approximate mass you need. So here I need about 0.2 to 0.3 grams. You can see on the balance that's about the right weight, so we're set there. Pop the lid back on the substance, you don't want it getting contaminated, and make sure that you put the lid back on your weighing vial so nothing falls in or out. Then off you go to the balance room, got your sample there. Make sure that the analytical balance doors are all shut and zero the instrument. After you've done that, double check, make sure it does say zero. You can then open the door, pop your sample in and slide the door shut. And you then want to take a reading of your initial mass, all 4 decimal places. Once you've recorded that mass, slide the door open, take your sample out and carefully transfer it into the flask that you're going to be working with. Make sure that you don't lose any on the transfer, so right inside the neck here. Pop the lid back on, there'll still be a little residue left in your vial, that's just fine. Make sure the balance still says zero, pop the vial back in and take the reading again. all 4 decimal places. This is called weighing by difference because the difference in mass between what you had earlier and what you have now will be the mass inside your flask. So you now know the exact mass that you've weighed by difference. If you need to transfer the mass into a standard flask or something with a narrower neck, you can use a glass funnel and transfer into this instead, and then afterwards use your wash bottle or solvent to rinse all of the solid into the flask and make sure it all gets into the receptacle. Right, that's the basics that you need in order to be able to weigh by difference. Good luck.
Okay. So that's weighing by difference. Baliktad, no? Baliktad siya sa weighing by addition. Ang sa weighing by difference class, pasok mo muna sa weighing bottle or any container na pwede nating gamitin. Pasok mo muna yung sample mo doon using the top load balance gihapon as ano gihapon siya as approximation sa desired mass nimo. Before nimo siya ibutang sa analytical balance, i-measure nimo and then i-transfer nimo ang imuhang powder or ang imuhang sample to the container kung asa jud ka mag-experiment. So, kung maghimo ka og solution, then i-transfer nimo siya sa Erlenmeyer flask or even sa volumetric flask. And then after, ibalik nimo sa analytical balance tong weighing bottle. It's okay kung naay nabilin sa sulod kay anyway, i-minus man to nimo. So, ma-appeal man siya dito sa weight sa container ang nabilin. So, ma-minus gihapon siya. And the same formula, weight of the substance is equal to the weight of the container with the sample minus the weight of the container. That's how you get the mass gihapon of the sample. But that's the most accurate one kay wala siya daghang movement nga himuon. Except lang sa pag-transfer sa imuhang sample sa imuhang flask. Makadistract iyang accent pas-pas pag yung istorya, no? We have questions, class, about the techniques.
Mas paspas ba ang weight by difference, ma'am, or paspas rin siya diyahang video?
Paspas lang iyang video, paspas po kayo siya mag-istorya. Pero actually, easier man ang weight by difference. And po siya? Actually, mas paspas po yun siya kaysa sa magsikag balhin-balhin sa weighing by addition. O sa the next time na mag-experiment mo ha, pag wala na tayo pandemic, dili na mo mubalik sa inyong old ways sa weighing. Kay wala ta kabalupuhon, mahimo mo og analyst sa laboratory. Wala lang ta kabalo, basig dili day mo ganahan mag community pharmacy or hospital pharmacy. Dito mo mag-analyst mo sa laboratory. We can do that as pharmacist. So, basig na aday nga na sa inyuhan, di mo kabalo mag-weigh. So, bagsak ta sa basics, ani. Questions, class? Wala. Okay. So, ang steps, syempre, bottle and then butangan og sample, ang approximation using the top load balance, tapos i-weigh sa analytical balance, i-transfer ang sample to the flask or container where you will conduct your experiment, and then i-weigh nimo ulit ang bottle and then i-minus lang nato para makuha natong weight of sample. So mag-public health day mo. Walay way dito sa public health. Okay? Sa community ug sa sa hospital na ay weighing, especially if pahimuon mo og you call that paper tubs. Uso na siya sa hospital ng paper tubs. Especially if bata ato ang pasyente tapos walay available na small dose, pahimuon man tag paper tub ani. So dapat accurate ang inyuhang weighing. So, dapat tama inyuhang skills, ang inyuhang method na nabalaan. Wala na may questions, class? Kaya mag-move on ta sa weighing errors. Wala. Sige, let's talk about the weighing errors. So, these are the sources of our errors, ang mga reasons nga nung magkaroon ta og weighing error. So we have the temperature, the moisture gain and evaporation, the electrostatic charge, and buoyancy error. So sa temperature class, kapag different gani ang temperature sa sample or sa object and ang temperature sa environment, mag-result siya into significant errors sa weighing. Okay? Ano man yun siya? The effect is known as dynamic buoyancy. And ano siya kanang naay variation sa error, dili mag-constant ang imuhang weighing anihang to dili ma-establish ang imuhang temperature. Dapat mapareho jud siya sa environment. Okay? So, kasi ang sample natin, we have film of moisture that changes with temperature. Kung musaka or mubaba ang temperature, mag-change pud ni ang film of moisture, and that will cause the variation. Pag ang inyong tandaan, pag cold ang temperature, actually the weight will be heavier. So, mo to dapat inyuhang gisulat dito sa inyuhang observation. Kaya diba sa activity, I have given the procedure, I have given the results, all you need to write is ang inyuhang observation. So, sa cold temperature, the substance will appear heavier, while in the warm temperature, it will become lighter. So, mo na siya ang effect sa temperature because of the movement of the film of moisture as the temperature changes. So, what are the sources of error due to difference in temperature? The first one is convection currents within the balance case that will exert a buoyant effect sa pan and sa object. Pag sinabi class na convection current, it refers to the transfer of energy. Remember, kapag naay difference sa temperature, there will be transfer of heat or there will be transfer of energy. And that transfer will actually have an effect sa both sa pan and sa object during the transfer of energy. May buoyancy na siya na effect or buoyant force. So magkaroon og changes sa measurement sa mass. And at the same time, aside sa heat transfer or sa energy transfer, kapag closed ang imuhang container, there will be warm air trapped inside, but ang kanang warm air is, ang iyahang weight is lesser. That is why kapag ang imuhang giway kay init, so lesser ang iyahang mass. Kapag kabugnaw, mas taas iyahang mass. Therefore, ang atong conclusion ani, before weighing, dapat naka-room temperature. Whatever is the temperature sa room or sa working area, dapat ingato pud ang temp sa ato ang gina-weigh. So, heated objects must always be cooled to room temp before being weighed. The same thing is true for objects from the refrigerator. Manatong mga pointers you should always remember, i-acclimatize sa atong mga samples before weighing. Dili pwede nga gikan sa ref or gikan sa oven, gidiretso sa pan. Okay? And then use tweezers because putting your hand into the weighing chamber will cause it to warm up. Okay? Kaya naay energy flow. Kung wala ta tong tawag ato tong finger nga nakalimot ko sa tawag saya. Wala ta ato nagagamit sa lab, you can use your gloves, okay? Use sample vessels with small surface area as they acclimatize fastest. So, pwede siya tong weighing bottle, pwede gamay na beaker, kay mas paspas to siya mag-acclimatize. When you say acclimatize, dapat pareha sila temp with the surroundings. And take note of this, kay inyo ba yung ginapatravel ato ang atong analytical balance, bisag asa na lang siya naabot. So take note that we have to position our balance away from heat sources, especially the windows, tutok kaayo ang sun, so init na ang environment din ha, mag-cause na siya og variation sa weighing, and even radiators. So Tarungon na to place no, dili pud nato itapat sa aircon ang atuang giveaway. Ay ato ang analytical balance. So nabugnaw na ang surroundings. It can add up to the weight. Questions class about the effect of temperature sa ating weighing. Wala. Dapat tong first year magud ni siya gitudlo sa inyohan yan. Abot na mag third year. Ibig kung saan na lang inyong ginahimo sa inyong analytical balance. Okay? And then we have moisture gain and evaporation. Actually, dili dapat first year. Dapat high school pa. Okay, di naman may chemistry. Moisture gain and evaporation. So, unsa inyong naobserbahan dito sa procedure o sa result sa activity. Natoy tulo ka substances dito. Sulfur, ethanol, and sodium hydroxide. Okay? So, na siya effect. Plus, ang atuang sodium hydroxide, it is considered as a hygroscopic substance. Pag sinabing hygroscopic, these are substances that absorb moisture sa air. Remember, ang class, ang Philippines is under zone 4 sa kanaganing climate regions. Pag moingon kag ang isa ka country under sa zone 4, it means that country is hot and humid. So sa Philippines, hot and humid ta. Meaning though hot ang atuang climate, pero ang atong air na ay moisture. Okay? So kapag ka ang substance hygroscopic, ano na siya, absorb na siya, whatever moisture, whatever air vapor ang nasa ato ang hangin, i-absorb na siya sa substance. So kung nakita ninyo dito sa example, sodium hydroxide is an example of a hygroscopic substance. When you place the sodium hydroxide na mga solids or pellets in an open container, it will absorb moisture sa air, magano na siya, magbasa na siya, and kadugayan actually mahimo na gyud na siyang liquid tungod sa pag-absorb. So during weighing, it can cause errors kasi naapil na nimo og ka-weigh ang water molecule nga iyahang na absorb. Now the other two substances are examples of volatile substances. So, kanang readily mag-evaporate at normal temperatures. Example, we have the ethanol. So, pag ibutang pud nimo siya sa open container, especially if the ethanol is 99% or absolute alcohol siya, dali na siya mag-volatilize. So, maka-affect pud siya sa imuhang weighing kay after some time, mubaba na ang iyahang weight. Okay? So, if you know that your substance is hygroscopic at the same time, at yung iba is volatile, what are we going to do? We have to use weighing vessels with narrow necks para, kung hygroscopic, limited ang air nga makasulod, and kung volatile po, dili siya basta-basta mag-volatilize. And then especially the most important thing is to use covers or stoppers para walay air and dili siya mag-volatilize. But avoid using cork bungs kay ni siya, dili siya ing ato ka-accurate when it comes to covering your material. Okay, and syempre, this is given. You have to clean your weighing pan from any dirt or water drops as it may add up to the weight of our substance. So do not forget Philippines is hot and humid. Let's differentiate it from zone 3. Zone 4 man ang Philippines. Zone 3, hot and dry. So example, kanang mga Middle East, kana sila ng mga countries, hot and dry na sila dito. Init at the same time, walay moisture ang ilahang hangin. Now, nganong kailangan nato mabalan unsang zone ta na belong kay when we manufacture the drug, we have to take into consideration the environment. Kay atong mga drugs, atong mga powders, there are drugs na hygroscopic, so kailangan we have to protect them from the humidity. Okay? Questions? Sa sa temperature? Wala. Okay. So how about sa electrostatic charge? This also causes unstable weighing because of drift and reproducibility. Actually, this is due to friction. During friction, there will be electrostatic forces. Tungod na siya sa mga charges, no, positive or negative. And na siya, depende kung mag-attract siya or mag-repel, basta magkaroon gihapon siya og interference or error during weighing. Therefore, it is important to use materials na dili siya reactive when it comes to charge. Kasi after rubbing, no, mawala raman tong charge, and then as the charge dissipates, mag-cause na siya instability sa atoang weighing. So unsa ang atoang kailangan tandaan? We have to use anti-static instrument para ma-neutralize ang charges sa surface sa atong mga materials nga gamiton. So unsa example sa atong mga anti-static na mga products or instrument, we have the gloves, the weigh boats, or natay mga anti-static class na mga glass or metal weighing vessels. So dili basta-basta nga bisag unsa na lang imuhang gamiton nga container during weighing. So basig ni gamit na ka like aluminum kana kay naagyud na siya charge, maka-cause gina siya friction with your sample, and ang consequence ana is variation sa imuhang result. So aside from that, we have to maintain the air humidity above 60% para to keep the charges ng neutral. Okay? And the last one, we have the buoyancy error. So this is another weighing error na ma-develop when you use a balance na naay weights, kanang mga weights na may predetermined na masses, tapos ang density atong weights is very different from that of your sa imuhang object. So most of the time, mahitabo ni siya kapag atong ginaway kay liquid. Kay ang mga liquid, lahira gyud ang ilahang density compared sa mga weights na naa sa atuang balances. So asa gikan ang error na ni, it actually mahitabo ni siya if merong difference in the buoyant force na gina-exert sa ato ang medium or sa atong air dito sa object and sa weights. So naa sila difference ang effect sa air dito sa imong sample tapos sa weight na imuhang gigamit. Mga bakal-bakal lang maning mga weights class, and then predetermined ang ilahang masses. Therefore, kapag kaing-ani na makita nato na layo ang difference sa density sa substance ug sa weights na atong gigamit, we have to correct the mass of the substance. We have to correct for buoyancy, and we will be using this formula. W1 equals W2 plus W2 times density of air divided by density of the object minus density of the air divided by density of the weight. So take note that the W1 is the corrected mass, and then the W2 is the mass of your object actually, the mass of your object. Ayan. And the density of the air, this is always given in the problem, and this is most likely constant, 0.0012 grams per cubic centimeter. Okay? And then, given po na siya sa problem, kuha man na nato density sa atong object, and sa mga balances nato, declared man ang density sa weights. So, example, ani, kaninga problem, a bottle with 7.65 grams empty. So ano man dyan na no, MTO na nga bottle. Actually, this is most likely weighing by addition. So empty, 7.65. And then, after adding the object, nahimo na siyang 9.97. So the object here or the sample here is an organic liquid and ang iyahang density is 0.92 grams per cubic centimeter. Now, since sa balance declared man ang mga weights nga gigamit, it's stainless steel for this one and the density is 8.0. So you can see the difference sa density nila. Therefore, we really have to correct the mass of the sample for the effects of buoyancy using this formula. Again, the density of air is constant. Now, question, asa gikan si 2.32? Wala man na siya sa given. 7.65, 9.97, 0.92, 8.0, 0.0012. So si 2.32 class, always remember this is the mass of your object. Siyempre makuha nato na siya by subtraction. Kay, di ba, weighing by, ano man siya, whether it is weighing by addition or weighing by difference, we really have to subtract first. Kasi, to get the weight of the sample, ano muna, container with the sample minus the weight of the container. So that's 2.32. I-substitute lang nato. And then density of air, 0.012. As you can see, density of object is 0.92. And density of your weight is 8.0. So, i-divide nato sila each before ta mag-minus. Ha? Siyempre, PEMDAS, una jud division before subtraction. And then, una jud lang nasa parenthesis. So, i-subtract nato na ang makuha na difference, i-multiply sa 2.32. Ang iyahang product will be added to the W2, the 2.32. So the W1, the corrected mass now is 2.32267 and so on. So ano na siya, from 2.32, actually dili man jud nga to kadako ang correction, but at least mas accurate ato ang mass. So 2.32 something. That's the correction. Questions, class, sa buoyancy error? We don't always do this sa lab. Wala ta kayo nag-correct sa ato ang mass. Kung unsa gihatag sa analytical balance mo na to. So again, ginahimo nato ni siya mostly sa mga liquid nato. So, tama po tong precautions na gi-report ni Rosel. Let's just add. So, make sure that i-center nato ang load on the pan. So, dapat na-adjust siya sa center. Basig nahiwi, no? Ang uban na sa kilid. Basta makaway lang, bites na. So, dapat naka-center gina siya. And then, we have to protect our balance from corrosion. Therefore, dili pwede ni direct nato butang atong sample dito sa pan. And, please, aside from that, dili ta mo gamit og mga reactive na mga materials. So, dapat non-reactive lang tanan. Non-reactive na metal, na plastic, or other vitreous materials. Class, kanang inyong ginahimo nga papel inyong ginagamit, mag-weigh, be careful, kasi ang papel is made up of carbon. And na siya, especially if imuhang gina-weigh kay kanang organic food nga substance, magkaroon na siya og reaction with the carbon sa paper. So, karon nag chemical reaction wa pa ka nakasugod sa imuhang experiment. Okay? And then, syempre, observe special precautions for weighing of liquids. Please do not spill liquids dito sa ato ang analytical balance kay maguba. And if kailangan og adjustment, you turn on the screw sa baba, but if dili kaya, you may call the instructor for help. And take note, dapat clean, no? We have to use brush to get rid of the spilled na mga materials or even dust. So, dili pwede nga tissue, papel, bisag unsa na lang ang ginagamit, or cloth. We use the brush, camel's hair brush. And katong sa effect sa temperature, we have to make sure na mag-cool down sa kung init and sa siya room temperature kung gikan siya sa sa refrigerator. Okay, and then use tongs or finger pads to prevent the uptake of moisture by dried objects. So dili pwede na you will hold the sample with your bare hands. Pwede siya source of contamination at the same time atong mga kamot class na adjud na siya oil. So kung gigunit nato na siya, magkaroon dyan na siya reaction with our material, maka-add siya sa measurement. Okay? So this one, addition lang sa gi-report sa group 1. Okay? Questions? Wala. So I hope you have learned the proper weighing, though wala man ta nag-experiment sa lab, pero namoy na-learn and how to properly do the weighing.